In 1961, President Kennedy called on all Americans to rise to the challenges of the day. He knew that success depended upon the unity of efforts throughout the federal government and the nation. The Greater Boston Federal Executive Board, one of 28 across the country, fosters communication, coordination, and collaboration with federal, state, and local government agencies. This is your federal government, and I am your host, Diane LeBlanc.
Hello everyone, my name is Kim Ainsworth and I am filling in for host Diane LeBlanc. Today we are featuring the Precision Oncology Program, a clinical care program with a research component intended to bring personalized health care and cutting-edge cancer treatment to our nation's veterans. The program is part of the Veterans Integrated Service Network 1. Our guest is Dr. Lou Fiore, the Executive Director of the Massachusetts Veterans Epidemiology Research and Information Center and the program's director. Welcome. Thanks for being here today. And that's certainly a mouthful. So why don't you tell me a little bit about the Precision Oncology Program and when it started?
Well, it's a pleasure to be here, Kim. Thanks for the opportunity to talk about this exciting program that's been in the works for about 2 years and has only been rolled out for the past couple of months. So about 1.5 years in design and about 6 months now in a sort of pilot phase. The program is funded by the VA New England healthcare system, and it's being run primarily from the Boston campus, but the other campuses in the network are also participating. The Precision Oncology Program is, I guess you would describe it as a application of precision medicine. The President in his annual address about the State of the Union mentioned precision medicine as being an important area for the future of medicine. And there's quite a bit of both private and public investment in precision medicine. And precision oncology is an application of precision medicine to cancer care. And so it's a pretty exciting time to be in precision medicine, and in particular for precision oncology.
Now, how does this program help veterans?
Well, what the program does is it helps doctors and other healthcare providers be able to care for veterans. And it does that in a way that's a little complicated, so let me explain that. When a patient develops cancer, uncontrolled cell growth, there's a problem with the cancer cells. And the problem is that these cells are continuing to divide and grow and cause tumors, which ultimately compromise and then cause the death of the patient. The reason why these cells are transformed, if you will, is because there's been a change in the genetic code, which is contained in the DNA of the cancer cell. That change is not found in the host normal cells, just in the cancer cells. So if you can compare the DNA of the cancer cell to the DNA of the host cells, you'd be able to detect what the fundamental differences are that account for the cell being cancerous. If you know that, then you can try to design effective treatments against those differences.
Now, is there any certain sort of cancer that you deal with more than others, or a specific type that are targeted with this program?
Well, in general, any cancer has the same principles operating, so that if one compared a cancer DNA to the normal DNA, you'd find a number of mutations. And so while it's generic to all cancers, in some cancers, there's been a lot of more work done in the area. The common cancers, and the cancers that have these genetic changes, which we'll refer to as mutations, that lend themselves to being treated. So we'll use the term targetable mutations, meaning that the gene product of the DNA mutation lends itself to drug therapy. And so lung cancer fits the bill. It's a common cancer. It has a number of mutations. Those mutations have been targeted by drug companies, and there are drugs in development to treat those patients. So what we did in our pilot phase is selected lung cancer. One could easily have picked a different cancer, but we wanted to show proof of concept that the strategy was working, and so we picked, I would call it a low-hanging fruit in lung cancer.
And how many, if you've been in operational just 6 or 7 months, how many cases have you had?
I think we've done about 150 cases so far, and in the early cases, we found that it was difficult to get enough tissue from the tumor to have it properly analyzed. The analysis is called sequencing, DNA sequencing. And so we had some problems initially with supplying the laboratories that are doing the testing with sufficient amounts of tissue, but we've overcome those problems. And recently, I think we've had a pretty high success rate. We've probably done about 150 cases of lung cancer so far. And now what we're trying to do is understand how best to get the information from the testing back to the patients and doctors, and how to help them understand what to do with the information and how the information can be of help. We're not forging new area necessarily here. Other leading cancer centers in the country are doing this, and so we're able to understand and leverage what they've done and apply it within the VA.
It sounds like precision medicine is pretty cutting edge, and you've taken it a step further with these other cancer centers and developed an oncology component to it. So it's exciting stuff. So, and it helps the clinicians develop a more targeted care plan for somebody with cancer. Is that correct?
Yeah, it does a couple of things. So let's say that you develop a symptom, a cough, some blood production in your sputum, and you go see a doctor, take an X-ray, and they find what is probably a lung cancer. In a traditional sense, you would get that biopsied. They would determine what the histology is, meaning what type of lung cancer, and then you would get general treatment for that particular lung cancer. And the general treatment would be radiation, surgery, or chemotherapy that was not tailored to your specific cancer. With this information in hand, we can sequence the tumor, determine what the mutation is that caused your tumor, and if there's a drug available, or if there's a drug that's being developed that we can get our hands on, we can deliver that drug to you, which is far more likely to be successful in treating the tumor than the traditional therapy, which is not based on your particular cancer. So the benefit is pretty immediate, provided that your tumor has a mutation against which there's a treatment. The real, I think, driving principle in starting the program in the region, as opposed to just in the one facility, is to see if we can export the technology to other facilities, so that no matter where you're seen, no matter what facility, no matter what physician, you're able to receive the same high quality care, and really it removes disparities in healthcare delivery that are due not to race or gender. These are traditional disparities, but disparities based on who's taking care of you and whether that facility happens to have a program. So I think in its wisdom, the VA has decided to try to create a standard approach, and it's in Vision 1 and it's in lung cancer. And so the real mission of the program is to improve patient care, particularly patients with lung cancer starting now, and to remove the disparities in healthcare.
Is everything done on site, so a veteran presents him or herself and has been identified to be part of the program? Does he or she stay with you from start to finish, and the testing and whatnot, everything done right on site?
Well, we have a centralized approach since there are 5 different sites that treat cancer patients in New England, but we're only located in Boston. So what we do is develop tools that allow the technology to be disseminated across the region. So for example, a patient presenting in Togus, Maine would have a biopsy done of a new lung cancer, and then would send that sample to a laboratory either in California or in Maryland that we have contracted with to do the DNA sequencing. Those DNA sequence results come back to us, we put them in the medical record, and so now the doc who's taking care of the patient in Togus has access to the same information as if the patient had been treated in Boston. So we have a disseminated resource system that delivers information back locally. Furthermore, if the doc sees the results of the test and the patient has an interesting mutation that they're not familiar with, which happens all the time because there are over 200 different mutations in each tumor, and which ones are the important ones and which ones have drugs against them, so-called targeted mutations, Docs don't have this on the tip of their fingers. And so what we've provided for them is through their own healthcare system, the electronic medical record, they can ask for help. And when they do that, they're given assistance by an oncologist who's very familiar with this, spends her career doing this at the Ann Arbor VA, works at the University of Michigan. Her name is Nithya Ramnath. And so using VA consultation technology already existing, peer-to-peer help can be delivered so that you're exactly right in that the doc sitting in togas needs do nothing. They can participate in the program. The resources that we bring to bear to facilitate the care are national resources, but they're delivered through the different technologies at the point of care where the patient is being seen.
Oh, exciting. So what's generally the turnaround time for something like this?
We like to get the turnaround time down below 2 weeks. You know, when you're newly diagnosed with a cancer, or if you've failed one treatment and you're waiting for the next, time can be of the essence. And laboratories have cooperated with us, and generally speaking, we're able to return results within 2 weeks, which is acceptable for the pace of patient care and decision making.
That's exciting. So you mentioned that this research it's got a research component. Is the VA a teaching hospital? Do they bring in, what's done with the research once you're finished with it?
Yeah, so the VA has a long history of participating in research. The three missions of the VA, first and foremost, is patient care. Number two is education. A vast majority of physicians in the country have rotated through some VA at some point in their training. And the third is research. The research typically is tailored to assist veterans, research that is particular to the needs of veterans. So things like PTSD, for example, Agent Orange exposure. But veterans develop cancer and the veterans develop heart disease, so that there's a broad portfolio of research that the VA supports. And I think it supports that research for two reasons. First, by doing research in the VA, particularly clinical trials and clinical research, the veterans who participate in those clinical trials get cutting-edge treatments, and that's very important. The second is that the training and research environment in the VA is really awesome for clinicians who want to remain academic. And so both the training and the research opportunities that the VA presents, I think, leads to enhanced retention of high caliber clinicians, affording veterans, I think, the best care anywhere. For the Precision Oncology Program in particular, there's a quite large research agenda that we're able to plug into the clinical program that I just described.
Exciting. So I guess you answered my question. So this has the potential to help a lot more than veterans. It's primarily you're focusing on veterans, but the research can be more widespread and help non-veterans as well.
That's correct. Anyone with lung cancer, whatever we learn, I've not described the research program, but whatever we learn from that research program will be generalizable to anyone, whether a veteran or not, obviously, with lung cancer.
So has it changed since it started? Is this what you envisioned when you, I guess it was 2 years in the process to put it together, but anything that you've noticed throughout the program that has modified it?
Are you talking about the clinical program or the research program?
Either.
Well, I mean, a lot have changed because we've learned so much about how to do this, from rather mundane things like turnaround time to important things like training clinicians who obtain biopsies on how to do that in a way that obtains sufficient sample for DNA analysis, to which are the mutations that veterans have. Are they any different than the general population? To what % of patients have a mutation that's targetable? In other words, is the program giving results that suggest that will be able to enhance care of the veterans? Or do they have mutations that are not targetable, and just acquiring the DNA and sequencing it sounds wonderful but doesn't accomplish anything? So we've learned a lot about what we're doing as we've gone over the last 2 years, 2.5 years.
And is there a particular age range, or it's from young to old and everywhere in between, or is there a certain era of veteran that you target?
We're, all comers who have lung cancer, we're accepting to test and try to help with. I guess the average age is somewhere in the mid-60s because of lung cancer, but we have a wide range, and we have some very young people. I guess another thing that has changed is that more and more docs are contacting us from outside of the New England system because they've heard about the program. And there's no reason not to include them. There are some technical difficulties in doing that because of the research program. So I guess that's another change. We've done a number of samples now for melanoma skin cancer, for example, for colon cancer. We're concentrating on lung cancer because we'd like to show success. And to do that, we think we need a critical mass of patients with one type of cancer where we become familiar with what mutations they have and what drugs we can get, and we actually deliver therapy to those patients. So we're starting with lung cancer.
So if there's a veteran watching this show who lives in Dallas, Texas, what is interested in it, what do you suggest he or she do to learn more or get involved?
Well, first they can just talk to their oncologist at the VA, and we've done some national education about the program, and so if they haven't heard about the program, their particular oncologist, they could easily get in touch with us in Boston. Karen Pierce Murray is the nurse who runs the project. We have an internet site as well. So what would happen is that patient would consult with their clinician, and if their clinician thought it was of value to have their tumor sequenced, and again, it need not be lung cancer, it could be any cancer, then they can use our apparatus to get that testing done. And what we would do is call their clinician back, call the pathologist, explain the process, facilitate the sample send out, facilitate the results getting back, and offer them some guidance if they need it on how to react to the results. And of course, we'd invite them to participate in the research part of the program.
And does the program have partners?
Yeah, as we've been doing this and thinking about how to do it effectively, what we've done is gone to places that have implemented programs already, such as MD Anderson in Texas, the Dana-Farber here in Boston. And in the course of our travels and due diligence, we've acquired enough attention and interest that folks have been coming to us to try to help understand what we're trying to do so that they could facilitate the process, because the VA is a quite large healthcare system, largest in the country, with 8 million folks. And so what we can do in the VA is pretty awesome with respect to the number of patients that we can support with precision medicine, and in particular now precision oncology. And it turns out that the more patients you have, the better the program is, because the quicker you can learn. And so we've created partnerships with University of California, San Diego, University of California, LA, Boston University, Stanford University. And in the private space, there are lots of different companies that are trying to understand what we're doing so they can generate a business model for this to happen outside of the VA. And while they do that, they're able to support our program. So it's a nice relationship that we've developed with a bunch of different. For example, the two companies doing the testing of the tissue, Personalis from Menlo Park in California, and Personal Genome Diagnostics from Baltimore. The first is a Stanford spinoff, and the second is a spinoff from Johns Hopkins. And those two companies have really supplied us with more value than simply doing the testing, but educating us as to what testing should be done. So these are the kinds of relationships that we've been able to develop.
So it sounds like they're very important, these partnerships.
They are. We can't do it alone, for sure.
So thus far we've focused on the clinical side of the house, but so how do you conduct the research with the program, and what do you think the outcomes will be?
Mm-hmm. Well, there's a couple of different research angles to this, if you will. So we'll get back to our patient in Togus who's presented with a new cancer, lung cancer. There's been biopsied, and we've sent the tissue, let's say, to Personal Genome Diagnostics, and they've returned back the results to us, and we've put them in the medical record. And it suggests that the patient has a tumor with a mutation that's treatable by an FDA-approved drug already on the market. Well, that patient will be treated in a routine fashion now, because there's nothing special that needs to happen to deliver that patient the right drug at the right time. On the other hand, let's say that the patient has an important mutation that's believed to be causing the cancer. We call these driver mutations. That's targetable, but the drug is in clinical trials. What we're able to do is make that drug available to that veteran using the clinical trial apparatus that we've been able to establish for the Precision Oncology Program. So in that case, a veteran is participating in research. The research happens to be a clinical trial. They're being given a drug that's in development that they probably would not have had access to, because it's unlikely that the Togus VA would have opened that clinical trial, because they would not have been able to anticipate that the patient would show up there with that particular mutation. By opening the trial regionally or even nationally, then we don't have to anticipate where a patient is going to present with a particular mutation that requires a particular drug. If the clinical trial is open nationally, wherever the patient presents, they can participate in the clinical trial. So it's a little complicated, but the first way that the program presents a research opportunity is to enroll patients in clinical trials. But distinct from that, there's a very exciting research agenda that we've put together, and it includes the following. We're back to our patient in Togus who has a newly diagnosed lung cancer. The sample was sent out. Mutations have been returned. There's no match. The patient has no driver mutation that has a targetable drug that's in development. In this case, they're referred for standard therapy. And about 1 out of 4 patients will fall into this category. But regardless, we approach all patients, whether they have a targetable lesion or not. And we ask them to participate in the research part of the program. What the research part of the program involves is patients allowing us to harvest all of their medical record data and to put it in a special data repository, a database, the Precision Oncology Data Repository. Into that same data repository, we put the information that we've learned about the genetics of the tumor, all the mutations, not just the ones we think are important, but all of them. And then we include in there things about the patient, their treatments, how they're doing, their x-rays. And we use this database to be able to determine patterns on how patients do in their cancer life and look for trends that might be able to help us better take care of a patient by knowing what's happened to similar patients. So for example, this patient who's presented in Togus is not found to have a mutation that we can do much about. We put their information in this database and we compare it to all the other patients in that database. And hopefully, when this becomes a national program, and we're in the process of rolling it out nationally, we'll be able to compare that patient to thousands of other patients who've had lung cancer with all different types of histories and all different types of mutations. A certain subset of those patients will match the patient pretty closely. They may be the same stage of cancer. They may have the same important mutation. They may have had a similar treatment. And by seeing how well those patients did, what they were treated with, we can learn maybe what to expect in this patient before us who has no definitive new treatment to give. And we can take that information and return it back to the doctor taking care of the patient. And now that doctor has really learned, if you will, from the experience of 1,000 patients, how to better take care of the patient sitting in front of them. Typically, a doctor would only learn from their own experience. They wouldn't be able to call upon the results of 1,000 patients. But by creating a database that does the querying for the doctor, you can now give the doctor information that is far beyond what their own experience could have been.
So it is voluntary. So when a patient presents, you present them with the information, they make their own decision as to whether to.
Yeah, so we approach the patient after the clinical care has been delivered and we say, we have a research component. If you would like to sign up for it, it would help us understand more about cancer. And we would publish that. So this is where the information we learn in the VA is disseminated outside of the VA. But more importantly to the veteran, by putting their information in the database, that allows us to take better care of them and of veterans in the future. And so really it's veteran helping veteran. And we're optimistic that the participation rate will be quite high because of that.
Wow, it sounds like exciting and cutting edge. Now you mentioned earlier that the administration has a priority in precision medicine. Can you just quickly define what precision medicine is for somebody who might not know what it is?
Yeah, well that sounds easy, but it really escapes precise definition. Precision medicine, generally speaking, is when you add information to a patient's medical record that is defining for that one person, and it's generally laboratory information about their DNA. So we differ from each other in many different ways, importantly in what we do, what we eat, how we exercise, and that determines our health and health status. But to a large extent, our DNA also determines what diseases we'll be at risk for, how we'll respond to different medications. And boy, wouldn't it be nice to have information in the medical record about your DNA, in addition to information about what diseases run in your family, whether you smoke or not, what your weight change has been. And so precision medicine attempts to study DNA, determine what your DNA is, and put into the medical record what we think are the important DNA mutations or changes that are unique to you. And the hard part then becomes in being able to see whether that allows us to take better care of you. And it's really hard to do that because we all have so many different DNA changes between us. It's hard to sort out what anyone means. So for example, you sitting there, me sitting here, if we compared our DNAs to each other, there'd be 3 million places where you and I are different. Wow. You have blue eyes, blonde hair, brown eyes, brown hair, height, weight. Yeah, you get the point. So with 3 million differences between two people, how do I know which of those 3 million, if any, is responsible for the fact that I developed diabetes and you don't? You need a lot of people who develop diabetes and a lot of people who don't, and to see which of the 3 million differences accounts for that. And so precision medicine attempts to deliver enhanced care and prevention. If you know what you're at risk for developing, you may modify your behavior to avoid that. And counseling, so you worry about your offspring. And so if you know what mutations you have, you might think one way or another about children. And so that's what precision medicine is in general. The problem, as I've already alluded to, is that to learn what these mutations mean, you need many thousands, if not millions of patients, because there are so many differences between people. So the VA has launched, and I think it might have been discussed on this program previously, the so-called Million Veteran Program, where we're capturing the DNA of 1 million veterans and adding that to the medical record, and then attempting to learn what these mutations mean, and by learning that, deliver better care for the veterans, which once it's published becomes generalizable knowledge. Precision oncology is way out in front of other areas of precision medicine because of a very important distinction. If I were comparing me to you, 3 million places where our DNA is different, tough to say if any of those are related to the fact that I developed diabetes and you don't. Change the paradigm. Now you're in Togus, you have a lung cancer. You sequence the lung cancer and you compare it to the expected sequence of germline. That's not going to differ in 3 million places because the tissue comes from the very same patient. Those two tissues are only going to differ by either a handful or up to a couple of hundred spots, far less than 3 million. And so when scientists then look at the differences in the DNA between tumor and host, the person who got the tumor's DNA versus the DNA of the tumor, you might find just 10 mutations if it's a leukemia, for example. And so by having a few mutations as opposed to millions, you can learn much more quickly about which mutation means which because of the much reduced dimension of the problem. So precision medicine, a lot of promise, long way to go, need millions of people, a lot of investment in research, and access to medical records to learn, which is a problem because medical records are kept very confidential, and how do you learn if you can't read them? Precision oncology, application of precision medicine to cancer, much less problem because of the dimensionality of the difference between the DNA of a host and the tumor.
Wow, well, it does sound very exciting and very cutting edge, and I think that we in New England are lucky to have it, and our veterans here are very lucky. And I want to thank you for using user-friendly terms. So those of us who are not in the medical field, just a couple of more questions. On each show we try to ask our guests to tell us a little bit about their career with the government and how you got where you are today. And I understand you've been with the VA for 34 years. So why don't you tell us a little bit about yourself?
Well, I'm not sure how interesting that would be to your viewers, but I'll tell you nonetheless. I've been with the VA for 34 years. I actually was an intern and resident at the VA in Jamaica Plain in Boston. I love the place. As one of my mentors said at his retirement dinner after working in the VA for 40 years plus, money never changes hands. And so it's all about taking care of business and helping veterans get through whatever it is they have to get through. There's really no financial incentive to not do or do something that should or should not be done. And that has been very pleasant for me, I would have to say. Additionally, the research opportunities that the VA allowed over my career have been another reason why it's been difficult for me to leave and why I have not left. So I continued doing a hematology and then an oncology fellowship, and then participated in research, 25% effort. Most of my time is spent taking care of patients. Over the last 34 years, that's flipped around till now where I do primarily research and just spend a month or two in patient care. But the research is always directed at taking care of patients, clinical research. And so it's been a great place for me to work. I think it's been a great place for a lot of docs to work. I would highly advise it for
Great.
Young clinicians in training.
Well, I want to thank you for your commitment, for all you've done for our veterans. And one final question, is there anything that I haven't asked you that you'd like our viewers to know, or anything about yourself or about the program or the VA itself?
I guess there's one overarching principle that I would like to put out there, and it would be that in order for us to learn what works best for precision oncology, patients, in this case veterans, have to agree to let us use their medical record data and understand what these mutations that their tumors harbor mean. And so sharing of medical record data is critical. And people are afraid to do that. There's the HIPAA, Health Insurance Portability Act, Privacy and Portability Act, but that's really conceived of as and implemented as a privacy and not a portability act. In other words, HIPAA prevents one from getting the health information from another. It enforces the confidence, which is an important thing, particularly if you want to get insurance or employment. Mm-hmm. But the downside of that is that it also makes it not very portable and difficult, therefore, for researchers to access. And so you have to get informed consent to use it, which is appropriate. But I think that patients participating, we're not going to be able to develop evidence-based treatments. That is to say, treatments based on us knowing what to expect from looking at other patients, unless people want to become part of the evidence. So you can't have evidence-based medicine without providing the evidence. So I guess a general call for people to be more participatory in research and allow for sharing, with their data. That's the first thing. And the second point I think is really important is that it's expensive to do this stuff. It costs money to do research. And most of that, if not all of that funding, comes from research bodies, whether it's the National Institutes of Health or whether it's the VA Office of Research and Development. But the dollars that are spent in taking health information and learning are quite small compared to the dollars that are spent on taking care of patients. If you look at the healthcare expenditures in the country and compare to that the research expenditures, it turns out that research gets about 1.5% of expenditures. So if you think about other major companies like Microsoft, if they spent 1.5% of their revenue on research, how long would they be Microsoft?
Right.
In the healthcare system, we seem to sort of say that research is going to show us what to do. Well, it comes to a certain point where research really can't do that, because research is designed to discover new drugs, but it's not meant to teach a healthcare system how to take better care of patients. So for precision oncology, we're trying to learn how to better take care of patients. My thought is that should be supported by the healthcare system, because they are the direct receivers of that knowledge. Research community is a 80-pound weakling compared to the 800-pound gorilla of the healthcare system. So the question is, how do you engage a healthcare system in understanding what research it should support to help it better take care of patients, as opposed to what research should be supported by industry, such as new drug development, because they'll recognize a reward for that when the drug is FDA approved and then gets sold. So there's two different kinds of research going on here. And that distinction is not really clear. And as a result, I think that that learning how to better take care of patients should be a higher priority. And the rubric for this is the learning healthcare system, the terminology people apply. So I think that the first plea was to folks to allow sharing of the medical record data for research purposes. Mm-hmm. The second is for healthcare system administrators to embrace things like precision medicine by supporting it and by allowing a research component within their clinical care environment.
Wow, that's certainly exciting. And I guess I learned something myself today too. So we absolutely want to try to support this, and we will make sure that our viewers get your website information and your telephone number. I grew up down the street from a VA hospital, and I know what a great place it is. I see the great work they do every day, and just walking through the lobby, you can see what a great place it is. So thank you for all you do for veterans every day.
Well, thank you for those kind words, Kim, and thank you for the invitation to come and speak here.
I want to thank our guest from the Veterans Integrated Service Network for joining us and for helping us better understand their groundbreaking work, and in particular, what the federal government is doing to care for our nation's veterans and to find cure for critical diseases. Thank you for watching. I hope that you will continue to join us as we feature other federal agencies on Your Federal Government.